Today we'll learn about the photoelectric effect. So this is a setup for the photoelectric effect. Okay. Now for the first, let us understand what is photoelectric effect. Now photoelectric effect is like when you have a metal plate and when a suitable frequency of photons are made to fall on the metal plate, the electrons start emitting out of the metal surface. So this effect is called as photoelectric effect. Now, same experiment wise, we can see here the experimental setup here. Now, for this, actually, we need a metal surface, a light source, and we'll identify what is the amount of charge, that is electrons coming out of it. We'll measure them in an ammeter. Now, look at this is a circuit for it. Now, here I have voltmeter, ammeter, and the metal, this is the metal surface on which light is made to fall. So this total setup we can see here. Now here we have an ammeter. This is the voltmeter, and we have a light source and a metal here. Now you can see here, this is the metal inside this. So this is a photosensitive metal. When light falls on the photosensitive metal, electrons are emitted from it. Now let us place this. So we'll first connect it. You can see here, the voltmeter positive is connected to the negative of the light source. That is, this is my voltmeter positive. It is connected to the light source negative. So I'll just bring it closer. This is light source negative. From the light source positive, it is connected to microammeter. The circuit first. Now here I have voltmeter. Voltmeter positive is connected to the metal surface negative. This is my voltmeter here. Voltmeter positive is connected to the metal surface negative. From the metal surface positive, it is connected to the microammeter positive. So this is the microammeter here. I have microammeter positive here. Then the negative of the ammeter is connected to negative of the voltmeter, and this is a power supply. Once you switch on the power supply here, this is the light source what we have. You can see here, this is the light source. So, when you place the light source in front of the metal, this way, you can see there is some current flowing here. Now, before that, we'll adjust this to 0. Now, so we have 3 different filters here. This is a green colored filter. Then we have a blue colored filter here. And I also have an orange colored filter here. Okay. Now let us place these filters one by one in front of the light source, in front of the metal surface, and let the light fall on the filter, through filter on the metal surface. Now once you place it there, now you can see that the voltage is 0 as of now, and there is some current flowing in this, right? Now I'll increase the voltage here such that the current value comes to 0. So this particular voltage is called a stopping potential. Now, note down the stopping potential values for different colors. Now here, we have a tabular column where we have different colored filters here and their wavelength values are given here. Accordingly, the frequency are also calculated. Now, what you have to do is find out what is the stopping potential for each of the colors and note it them this way. The stopping voltages for different colors. Now that we have finished with this filter, now replace this filter with one more filter. And note down but then first bring this voltage to 0, replace the filter with another color filter, then again increase this voltage similarly as we have done earlier, such that your current value shows you 0. So the current value is 0 now. Similarly, for this particular filter, this is the stopping potential 0.29 something. Okay. This way you do it for all the other color filters also. Note down the stopping potentials. You have the formula here to calculate the Planck's constant. The Planck's constant H is equal to E into V2 minus V1 into lambda 1 lambda 2 divided by C into lambda 2 minus lambda 1. Now what is this E? E is the charge of the electrons. V1 and V2 are the two stopping potentials of any two colors. So we need to do this for any two colors at a time. Like either I can take green and blue, or blue and orange, or green and orange. This way, for any two colors at a time, we'll do it. So here, H1 is for the first combination of V1 and V2 of stopping potentials, and H2 is a combination of other two stopping potentials, and H3 is a combination of other two colors combination. Now here, to find this H1, that is nothing but H. So we have V2 and V1 values just now noted from the voltmeter. Now lambda 1 and lambda 2 is for the wavelength of those colors which are, when the filters colors, what we have used. Suppose if it is a green color, the value of the wavelength ranges between 4900 to 5700. So this way, for all the other colors also, the wavelengths are given and their frequencies are also given. So here we have V2 minus V1 into lambda 1, lambda 2, which we calculate from this, divided by C value is actually speed of light, which is 3 into 10 to the power of 8 meters per second. So substitute the C value here, and again substitute the lambda 1, lambda 2 values here. So this way, we'll identify the H value for different combination of colors, so that we...
Okay, so after we note the values of all the values of H1, H2, H3, now take the average of all of them, so you get the value of H, that is Planck's constant. So this is the value what we have found from the experiment. Now let us also draw a graph between the frequency versus the stopping potential. Okay, so once we draw the plot, now you see that like after you mark the points, this you draw a straight line, and this straight line cuts the x-axis at a point. Now this point is a threshold frequency which we noted as mu naught. Now once you have this value, now you have to find the value of H from the slope of this straight line. That is, you can see here in the formula, H is equal to E into the slope. E is the charge of the electron into the slope value. Slope is the stopping potential by the threshold voltage. So once you have the slope here, substitute it here, you will get the H value from the graph. Now, you also have to find what is the work function. For finding out the work function, we note this value of threshold frequency. The threshold frequency into the value of H what you got, that is W is equal to H into nu naught. This will give you the work function of the system.